doing lesson 6.2, radicals and rational exponents. Is there anyone who remembers what a radical is? Square root, all right? If you recognize this, you recognize a radical, all right? What about a rational number? Does anybody remember what a rational number is? Rational numbers are numbers that can be written in fraction form. So you'll notice if the title says rational exponents, that means today we're going to be looking at exponents that are fractions. Yesterday, all of our exponents were whole numbers. So it's going to be a little bit different. We're also going to be dealing with radicals today. So the essential question says, how can you write and evaluate an nth root of a number? So grab your highlighters and right off the bat, I want you to highlight radical form to rational form, because we are going to be going back and forth between radical form and rational exponent form. Now you'll notice in both of these forms, there is an N and there is an A. So it's very important that you understand what the N and what the A represent. So it tells us here that N is the root. Now you say, what is the root? Well, all of you have seen this before. How do you read that right there?
4. What is the square root of 4?
The square root of 4. So what is the root of that problem? 2. The square root. Now that means that they don't have to put a root of 2. There's an understood 2 right there. All right, but now what happens when they start putting a 3 there? Now they want the third root. They might put a 5 there. They want the fifth root. All right, so you have to understand that the number that sits out here on that ledge is called the root. All right, the A, the number that is under the radical, is called or is a real number. Now we called it something else yesterday. If you look at rational form right here, okay, what did we call that number right there?
Base.
The base. So if you wanted to, you could also add in your notes the base, because when you hear me talk about the base, you're going to want to understand that that is the A in these problems. Now let's talk about the N or the root. When the root is odd, you're going to have one real root. Essentially, you're going to have one answer. So that's when you have a radical sign and there is an odd root sitting on that ledge. When your root is even, and this is the one, another one that I want you to highlight, because this one, if you don't pay attention, you will miss this. When the root is even, so let's say we have a radical and there's a 4 sitting out there. When the root is even, you actually have 2 answers, 2 real roots. Because if you go back up here to the square root of 4, and I'll just bring it down, what is the square root of 4? It's 2, but it's actually positive 2 and negative 2. Because 2 times 2 is 4. But what is negative 2 times negative 2?
4.
Also 4. So when your root is even, so I want you to highlight that because that's important. We've got to look for that. If we don't look for that, when we're boxing in our final answer, we might miss it. So if the root is even, we have to make sure we include that little plus or minus sign in front of our answer. Now, what if the root is even? We'll use 6 this time. And the A, the number under the radical, is a 0. Well, that means there's only one real root. There's only one answer. Any guesses at what that answer would be? 0. Okay, the only way to get 0 is to multiply 0 times 0 times 0 times 0 times 0 times 0. Okay, the 6th root, it's got to be 0. All right, now the last one is when the root is even and the number under the radical, the A value, is less than 0. Guys, what kind of numbers are less than 0? Negative. So let's say there's a negative 3 under there. If the root is even and the number under the radical is negative, there is no real root. There's no answer. There's no solution. But I need you to be careful, because what if I give you a radical and the root is odd and has a negative underneath? Does it say anything about us not being able to work that? No. All right. So we're really just looking. If there's a negative under the radical, we should stop and think and look at the root. If the root is even, then we'd write no solution and we would not waste our time. Now, let's look at example number 1. It says, find the indicated real nth root of A. Now, we're going to do that, but I'm also going to ask you to do something that is not in the directions, all right? Because I am preparing you for a couple homework questions that you're going to see tonight, all right? Let's start by putting the problem, though, into radical form. So if you go back to the top of your notes, you see the formula. Go ahead and write down the formula. The root is on the ledge of the outside, and the A is underneath. So this should be very simple for us to plug in. what is the root of this problem that they've given us? 3. And what is the number under the radical? Negative 125. Now remember, the negative under the radical should cause us to pause for a minute. But look at the root. The root is what kind of a number? Odd. So are we able to carry on with this problem? Yes. All right. It's only if the root is even that we'd have to stop and say no solution. But this root is odd, so we're going to keep going. Now, what the directions don't ask us to do, but I'm asking you to do, I want you to now take this and put it into rational exponent form. And let me make this as simple as possible. The power under the radical has to come out completely. Now, when I say completely, I'm saying that because if you look under the radical at negative 125, what understood power is it being raised to? Right here. What's it being raised to? The first. So when I say the entire power has to come out from under the radical, I mean the entire power. So negative 125 raised to the first power. I have to pull out and write down the entire power. Now, the only reason I'm putting this number in parentheses is because it's negative. If it was not a negative number, I would not have to put it in parentheses, but it is. Now, that leaves me with one number in radical form. What do I do with the root? Well, I go to the exponent of 1. The exponent is supposed to be a fraction, so I put the fraction bar. The root becomes the denominator. And now I have negative 125 raised to the power of 1/3. That is rational exponent form. Now, to work this problem, though, we're going to go back and we're going to focus on the radical form. Okay? Now, unfortunately, we cannot just grab our calculators and let our calculators do all the work. I would love to tell you to do that. However, you're going to face an SAT. You're going to face a PERT test, those of you that want to get into dual enrollment, and you are not going to be able to use a calculator on this. All right? You have to know how to simplify radicals without a calculator. So that is why we are without our calculator today. Now, you have learned how to simplify a radical, but let's see if you remember. By show of hands, who remembers upside down division? Okay? That is what we're going to do today. So we're going to take the number under the radical, and we're going to do upside down division on it. Now you say, Ms. Johnson, that's a negative 125. You're right, but we'll pull the negative down at the end. Let's not worry about it while we're doing our upside down division. Also, for those of you who may be a little rusty on upside down division, we are only allowed to divide by what kind of numbers? Prime. So let's list some of our prime numbers. What's the very first one?
3.
Okay. All right, I heard 1, I heard 3, I heard 2. Let's talk about it. First of all, 1 is neither prime nor composite. Okay? 3 is a prime number, but it's not the first one. Remember prime numbers. Numbers whose only factors are 1 and the number itself. So that definitely would take us to 2. 2 is prime because the only way to multiply and get 2 is 1 times 2. Now, 3 would be the next one. What would come after 3? 5. Okay, what would come after 5? 7. What would come after 7?
11.
Good. Go all the way to 11 and then usually 13. We don't normally have to think any higher than that with upside down division. Okay? So, if you've forgotten, this would be a nice little note to add. Now, let's go back to 125. What prime number goes into 125? 5. Anything that ends, any number that ends in 5 or 0 is divisible by 5. Now remember, we don't have calculators, so we got to be careful. 5 goes into 12 twice, but that's only 10, so there's 2 left over. So I take the remainder and put it beside the next number. 5 goes into 25 5 times. What prime number goes into 25? How many times? 5. Okay? Once I hit a prime number, I'm done dividing. And this is where I have to be careful. Typically, we're looking for pairs, right? But that's because the root has been squared all this time. What is the root of our problem? 3. So we have to find sets of 3. All right? So we go, do we have a set of 3 5s?
Yep.
Yes, we do. Now, just like the pairs, the set becomes just one of that number, and it comes out from under the radical. So I'm going to go ahead and write the 5 down, but I'm going to be careful because it was a negative 125, which means my 5 has to be what?
Negative.
I have to pull down the negative. Let's put b into radical form. We know it's the nth root of a, so when we plug in, what is the root that we plugged in? 6, and the number under the radical? 64. All right? Now, I want you to quickly put it into rational exponent form. And someone raise your hand when you're done and tell me what it gives you. 64 and 1 6. Now, let's see if she is correct. First of all, underneath the radical, you have a 64 raised to an understood 1. So she pulled the entire power out and wrote it down. That's 64 to the first. And then the root became the denominator of her exponent. Very good. Now, you focus on the radical form for the upside down division. So what are we doing upside down division on? 64. All right, what prime number goes into 64? 2. It goes in there 3, goes in there 2, so 32. What prime number goes into 32? 2. 2 goes into 3 once with 1 left over. 2 goes into 12 6 times. 2 goes into 16? 8. 2 goes into 8, 4, and 2 goes into 4, 2. Now, what is my root this time?
6.
So I am looking for sets of 6. Do I have a set of 6 2s? Yes. And again, the set becomes just one of that number. So I'm going to go ahead and write down the 2, but I'm going to wait because the root is what this time? It's even. All right, remember, what did we say? When the root is even, how many answers are we supposed to have? 2. So this should be plus or minus the 2. So we've just got to make sure if the root is even, we go put the plus or minus sign in front of our answer. Now let's go to example 2. This says evaluate the expression. Now here's the good news. If the problem is in radical form, we're just going to go right into solving it. If it's in rational form, though, we're going to take it back to radical form. Otherwise, we run the risk of not actually doing upside down division on the right number. Okay? So looking at letter A, what form is it in?
Radical.
It's in radical. We pause for a minute because there's a negative under the radical, but the root is what kind of a number? It's odd. So can we go on with this problem?
No.
Yes, we can. All right. The only reason we can't is if the root was even. So what is the number that we are going to do upside down division on? 216. Again, we know it's negative, but we'll pull the negative down at the end. All right. I'm going to do my work over to the side so that I have plenty of room. What prime number goes into 216? 2. Now 2 goes into itself once. It does not go into 1, so that gives me a remainder of 1. And 2 goes into 16 8 times. What prime number goes into 108? 2. 2 goes into 10 5 times. It goes into 8 4 times. What prime number goes into 54? 2. 2 goes into 5 twice with 1 left over. 2 goes into 14 7 times. What prime number goes into 27?
3.
How many times?
3.
9. What prime number goes into 9?
3.
How many times? 3. Now, we're looking for sets of how many? Again, my root is 3, so I'm looking for sets of 3. I've got a set of 2s, and I have a set of 3s. Now, each set becomes one of that number, and this is the first time that we have seen this. So let's make sure we write this down. We have a 2 coming out from under the radical, and we have a 3. We also know that 216 was negative, so I'm going to go ahead and pull the negative down. What are we supposed to do to 2 and 3?
Multiply them.
Multiply. That makes the most sense, right? We were just doing upside down division. So hopefully it makes sense that we would multiply whatever numbers come out from under the radical. So that makes my final answer what?
Negative 6.
-6. Now, letter B. What form is letter B in? Rational exponent form. So we need to take it and put it into radical form. Now we've got to think backwards. Remember, the entire power came out from under the radical, so the entire power has to go back under the radical. What is the entire power here? That's the base. Look at that. The base of -64 and the numerator. That is your entire power, and that is what has to go back under the radical. Now, it is a -64, so once again, I'm keeping it in parentheses, and I'm squaring it. What does that make the root of my problem? 3. Okay, so the root goes on the outside. Now, here's what you got to understand. They're asking you for the third root of -64 squared. So if you took -64 and squared it, you would get 4,096. Is there anyone that would like to sit here and do upside down division on 4,096?
No.
Okay, so let me teach you a quick way to do this. We're going to take what's under the radical and we're going to expand it. So -64 squared actually means what? -64 times -64. So we're writing it out the long way, if you want to call it that. All right? Now that allows us to just focus on one of the 64s. Okay? So we are going to take, again, don't worry about the negative right now. We're going to take just 64 and do upside down division. Instead of 4,096, we're just going to use 64. So what prime number goes into 64? 2. Goes in 3 times, goes in twice. Now here's a number we've seen before, so we should be able to move through this quickly. 2 goes into 32, 16. 2 goes into 16, 8. 2 goes into 8, 4. And 2 goes into 4, 2. Now, we're looking for sets of how many?
3.
Good. Again, my root is 3, so I'm looking for sets of 3. I've got 2 sets of 3. So each of those becomes a 2. Now, at this point, as long as I can see that work, I'm okay if you do 2 times 2 in your head instead of writing it down. What then comes out from under the radical? 4, right? 2 times 2 is 4. So we're going to write down the 4, but remember it was negative 64, so that's actually a what coming out? Negative 64. Now, here's the key. That is not my final answer. I go back to the radical. How many negative 64s were under the radical?
2.
So how many negative 4s have to come out? 2. So once I write 2 of them down, then I can do my math. What is negative 4 times negative 4?
16.
That is your final answer. When we put this into radical form, what goes underneath the radical, Kennedy? 9 to the 5th power. Now, again, if you're highlighting, show yourself. The power is 9 to the 5th. That's what goes under the radical, which makes the root of this problem what? 2, okay? Now, you have options here. Leaving the 2 off is okay because there's an understood 2 on these radical signs. Or, if you're visual and you want to, you can put the 2 there. It does not matter. But now we expand what's under the radical. So 9 to the 5th, what does that actually mean? 9 times 9 times 9 times 9 times 9. Now, that means we're going to focus on just what number? 9. And you could do upside down division, but what a waste here. This is the square root of 9. This is nothing fancy. What is the square root of 9? 3. And how many 9s are under the radical? So there were how many 9s under the radical? So how many 3s have to come out from under the radical? 5. So 3 times 3 times 3 times 3 times 3. And all we have left to do is multiply. What is 3 times 3?
9.
Times 3.
27.
Times 3. 81.
81.
All right, look, if you're not sure, just do a little math over here to the side. 81 times 3?
204.
243. Now, take a pause for a second. Look at your root. Is your root even or is your root odd? It is even. Remember, it's an understood 2 right here. So my final answer is not just 243, but it's plus or minus 243. Start by putting this into radical form. Sarah, what is underneath the radical? 256 to the 3rd power, because the entire power has to go back under the radical. That makes your root a what, Sarah? The root is 4 this time. So underneath the radical, Sarah, if you expand that out, what do you have under the radical? Good. 256 times 256 times 256. Now, I believe 256 to the 3rd power is, they told me earlier, something like 14 million, and nobody wants to do upside down division on that big a number. So this allows us to focus on which number for upside down division? 256. It's under there 3 times. We're going to take it and do upside down division on it once. Okay, what prime number goes into 256? 2. 2 goes into itself once. It goes into 5 twice with 1 left over. It goes into 16 8 times. What prime number goes into 128? 2. It goes in there 64 times. We're seeing familiar numbers again. 2 goes into 64 32 times. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 twice. Now, Ayana, how many sets are we looking for this time?
4.
We're looking for 4. The root is 4. So we've got a set of 4 here and a set of 4 here. So again, each set becomes one of that number. And Ayana, what do we do with the 2 2s? So what is coming out from underneath the radical? 4. Now, how many 256s were underneath the radical?
3.
So how many 4s have to come out? So 4 times 4 times 4 is what? 64. But take a pause. Go back and look at the root. The root is what? Even. So what does your final answer have to be?
Plus or negative?
Plus or minus 64. And that would be your final answer. That is lesson 6.2.